Okay, welcome to the fourth video in the SaMi lecture series for the pre-AMC 8. I'm Olivia, and let's get started. So we've got a circle with two distinct lines are drawn on a sheet of paper. What is the smallest possible number of points of intersection of these figures? Okay, so we've got circle, and we want this and two lines that are different, right? So they can't, we can't just draw one line and then another line on top of it. We want the largest possible number of points of intersection. So ideally, we have as many points crossing as we can. So let's start with one line, right? So we can either put the line, there's three choices. I'll draw it over here. Either the line goes on, touches the circle briefly, it goes through the circle, or it's away from the circle. And if we want the line to touch as many points on the circle as possible, we're going to go through it. Okay, and now the next line. So for that line, we want it to touch as many points as possible, so ideally it touches the circle twice and the other line once, right? So here we've got kind of an X, and that has 1, 2, 3, 4, 5 points of intersection. Answer choice D is the correct one. How many combinations of $5 bills and $2 bills can be used to make a total of $17? All right, well, let's do some casework for this one, right? So what are our options? What are the different ways we could make $17? So either we use 0 $5 bills, one $5 bill, that's kind of confusing, two $5 bills, or three $5 bills, right? If we use more than three $5 bills, then we have four $5 bills, and that makes $20. So here are our cases. No $5, one $5, two $5, three $5. Okay, but do all of these cases work? If there aren't any fives, can you use just $2 bills to make $17? Well, we can see that 17 is an odd number, right? So we can't count up to it using just multiples of 2. 17 isn't divisible by 2. It's going to have a remainder. There's a remainder. So that won't work, right? So when there aren't any $5 bills, we can't make $17. Okay, what if there's one $5 bill? So you've got $17 minus the $5 bill. That's going to leave us with $12. Can you make $12 using just $2 bills? You can, right? 12 is divisible by 2, so this case works. Okay, what about two $5 bills? In that case, we've got $10 worth of $5 bills, right? 2 times 5 makes 10. And we subtract that from $17 to get $7 that we need to make out of $2 bills. Is that possible? Can you make $7 out of just $2 bills? Nope. Just like for the same reason we can't do it with the 0 $5 bills, 7 isn't divisible by 2. We can't do that without a remainder. So that one doesn't work. Okay, what about three $5 bills? 3 times 5, that makes 15. So we need plus 2 more dollars to get to 17. Can you make $2 out of just $2 bills? Yeah, you just use one $2 bill. So this case works as well. So that's the case with one $5 bill and the case with three $5 bills. Those two cases are our answers. Okay, what's the smallest possible average of 4 distinct positive even integers? Okay, that's a lot of terminology, right? So let's break down some definitions. So we want average, and we need 4 distinct, important to remember, positive even integers. Right, so it needs to be bigger than 0, it needs to be a multiple of 2, and they need to be 4 different ones. Right, so here are options. We have 2, 4, 6, 8, 10, on and on and on. Right, those are even integers that are positive. Okay, and we want the smallest average possible. So that means if we add all those numbers up and we divide it by 4, we want that to be as small as possible. Okay, well, thinking about it, if we want it as small as possible, we're going to have to use the smallest numbers so that their sum is minimized. Right, so what are our smallest positive even numbers? Those are 2, 4, 6, and 8. 2 plus 4 plus 6 plus 8, that's 20, divided by 4 is 5 as our smallest possible average. All right, moving on. Okay, we need the product of the digits of the next year after 2002 that is a palindrome. Remember, palindrome, same forwards and backwards. Those could be letters to like words. I'm sure maybe you've heard of taco cat. That is a palindrome. Spelling it backwards is also taco cat. So in this case, our palindrome is with numbers. So that means that you could write the number out the other way around and it would still be the same, right? 2002 backwards is also 2002. All right, so what's the next palindrome after 2002? Well, we've got two sets of numbers we could change, right? So either we change the 2 or we change the 0. If we made the next biggest number after the 2, that would be 3003, right? That's pretty big. Let's see if we can have another one. What if we increase the 0 instead? Instead of 2002, we have 2112. That looks pretty good. That's our next closest palindrome, right? That's less than 3003. So that's our next palindrome after 2002. And the product of its digits, so that would be when you multiply all of the numbers together. So 2 times 1 times 1 times 2. What does that equal? 2 times 1 is 2, times 1 is still 2, times 2 is 4. So that's the product of the digits. Remember, product, think multiplication. Okay, Carlos was born on Saturday, November 9th in 2002. What day of the week will Carlos be 706 days old? Okay, so let's think about that. So we know that Carlos was born on Saturday, so we'll start with a Saturday. I don't want to count out 706 days. That's kind of boring, right? We draw out a calendar here. We've got our Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So here's Carlos's born. When he's 1 day old, it'll be a Sunday. 2 days, 3 days, 4 days, 5 days, 6 days, 7 days. I'm not going to do that 706 times. That's kind of a lot. But if we do it a couple times, we can start to notice a pattern. Right? We see that every time Carlos is a multiple of 7 days old, right? That's on a Saturday. So on a Saturday, he'll be 7 days old. The next one, he'll be 14. After that, he'll be 21 days old. And it keeps going like that. Right? So we could find what day of the week it is relative to how much of a multiple of 7 his age is. So that might be a little confusing, but let's get started. So, for example, 706 divided by 7 goes in once into the 7, 0, and then 0 with a remainder of 6. Right? So that means he wasn't born, or when he's 706 days old, it's not another Saturday, right? Because those are always multiples of 7, so we can cross that out. Okay, on Sunday, he's always one more than a multiple of 7 days old, right? 1 is more than 0, 8 is 1 more than 7, next time he'll be 15, that's 1 more than 14. So on Sundays, he's always 1 more than a multiple of 7, and we want 6 more than a multiple of 7. Okay, Monday, he's 2 more than a multiple of 7 days old, right? 2 is more than 0, 2 more than 0, 9 is 2 more than 7, 16 is 2 more than 14, so Monday doesn't work either. Wednesday, our next option choice, he'll be 4 days older than a multiple of 7. 4 is 4 more than 0, 11 is 4 more than 7, same like that. So Wednesday isn't it either. It's only on Friday when Carlos is 6 more than a multiple of 7. So we can see here the 6, the 13, after that the 20. He's always 6 days older than a multiple of 7 on Friday. All right, so we're looking at a graph that shows a bird bath filling, right? It's got a filling time and then an overflow time. And the reason it overflows is because the bird bath gains water at 20 milliliters per minute and loses water at 18 milliliters per minute. So it's always getting more water than it's losing. So when it reaches here's my pretty little bird bath. When it reaches its filling capacity, it's going to start to overflow. That is water. So we need to find a graph that shows a filling time, right? And then an overflow time. So let's start with the filling time. Which graph shows the volume of water in the bird bath increasing, right? Because it's going to start at 0 and it's slowly going to fill up. A shows that, right? Here we've got an increase. B doesn't, right? It starts full, which isn't the case with our bird bath. C has an increased time. That's good. D doesn't have an increased time either, right? It's also starting full, which we don't want. And then E has an increased time as well. So we can keep A, C, and E. Okay, now what's going to happen during the overflow time? That one's the tricky part. So even though water's spilling out, right, because it's overfull, the bird bath isn't losing water. It's always going to stay perfectly on top because it's always getting more and more water. So it's never losing height, right? So it's not going to be able to keep filling up at some point. It's not just going to keep on going forever like C does. That's not possible. But it's not going to go down either. The water is going to stay at the max fullness. It's always going to stay constantly full. And that is best shown with graph A, right? Remember E, our water is never going to go down. The water level never decreases. And remember, see if you can read the problem on your own, pause the video and read the question on your own, and then try it before I present a solution. Okay, we've got students in Mrs. Sawyer's class taking a test, or asked to do a taste test of 5 kinds of candy. Each one chooses one. What percent of her class chose candy E? Okay, let's see how many people chose what kinds of candy. Right, here we've got 6 people with candy A, 8 people with candy B, 4 people with candy C, 2 with D, and lastly 5 with E. So that's 5 total people out of how many? Well, we know there's 6 plus 8 plus 4 plus 2 plus 5. That's the total number of kids in Mrs. Sawyer's class, right? Because they each chose one candy as their preference. So 6 plus 8 will be 14, plus 4 is 18, plus 2 is 20, plus 5 is 25. There's 25 students in Mrs. Sawyer's class. So basically what this question is, what percent of 25 is the number 5? So 5 over 25 equals some number, which we want to figure out, over 100. Okay, well, let's think about this. How do you get from the number 25 to 100? Well, you can multiply by 4, right? 25 times 4 is 100. And we can do the same thing with the 5 to get our top number. 5 times 4 makes 20. So because we have 5 over 25, and we're multiplying it by a number that's the same as 1, right? We're multiplying it by 4 over 4, which you can simplify to 1. That doesn't change the fraction, right? Multiplying anything by 1 will keep the number the same. So 5 over 25 times 4 over 4 equals 20 over 100. That means 5 is 20% of 100. And that's the percent of her class that chose candy E. Alright, let's figure out, we want to find out how many of his European stamps were issued in the 80s. Alright, so we see, this is something good to know, but it's helpful that they include it here. So our European countries in this case are France and Spain. Right, these 2 countries. We want to find out how many of those stamps were issued in the 80s. So that would be this column of our graph. So we see in the 80s, his collection of French stamps is 15. He has 15 French stamps from the 80s and 9 Spanish stamps from the 80s, right? That would be this column showing that and this one. So 15 plus 9, that is 24 stamps that he has that were issued in the 80s from Europe. We want to find out how much Juan's South American stamps that were issued before the 70s cost him. So before the 70s, that one's tricky, so that doesn't include the 70s. So we want only on the left side of that line. And then we want the South American stamps. That's Brazil and Peru. These two countries. So we can see from the question, the prices he paid for the stamp shop were for Brazil and France were 6 cents each. So that's 6 cents for Brazil. And Peru was 4 cents. All right. So Juan has Brazilian stamps from the 50s and 60s, and he has 4 from the 50s and 7 from the 60s. 4 from the 50s, 7 from the 60s. So a total of 11 Brazilian stamps that were issued before the 70s. And as for his Peruvian stamps, the ones from Peru, he has 6 from the 50s and 4 from the 60s. 6 plus 4 is 10 stamps from Peru. All right. We know the Brazilian stamps cost him 6 cents each. So 6 times 11, right? That is 66 cents. 66 cents that his stamp collection cost him. And the Peruvian stamps, there's 10, and they cost him 4 cents each. So 10 times 4, that's 40 cents. So 40 cents plus the 66 cents, that's the total of 106 cents, which is answer choice B. All right, and now we want to find the average price of his 70s stamps. So in the 70s, he has 12 Brazilian stamps. Those cost him 6 cents each. 12 French stamps that also cost him 6 cents each. 6 Peruvian stamps. Those cost him 4 cents each. And 13 Spanish stamps, which cost him 5 cents each. So now we want to find the average. And something we can do is we can notice right away our answer choices, right? It's going to be some number between 6 and 4, right? Because that's our range. So it's not going to be greater than or less than those. So his average isn't going to be 3.5, right? And it's probably going to be bigger than 4, right? Because every other number, we have some 4s, but most of the other numbers are bigger. So those are 2 answer choices we can eliminate. So let's do the rest. 12 times 6, we've got 72 cents for his Brazilian stamps. Another 72 for his French stamps. 6 times 4, that's 24 cents for his Peruvian stamps. And then lastly, 13 times 5, that is 65 cents for his Spanish stamps. Adding that up, that's 233 cents. And we're dividing it by the total number of stamps. So that's 12 plus 12 plus 6 plus 13. That's 43. Right, so 233 divided by 43, that's closest to 5.5 cents. So we've got a sequence of squares and identical square tiles. And the edge of each square is 1 tile length longer than the edge of the previous square. Okay, and here we've got the first 3 squares. And we want to know how many more tiles does the 7th square require than the 6th. All right, so let's see if we can notice a pattern of how many more squares each one requires than the one before. So our first one has 1. Our first square has 1 square tile. Our next one has 4. And then after that, we have 9. Right? So how much are we increasing by every time? So first we're increasing by 3. Then we're increasing by 5. Okay. How would we continue on? Well, the next one we know going to have 1 more edge than the next one. So instead of a 3x3 square, we've got a 4x4 square. So that's 4x4. That has 16 tiles. And from 9 to 16, that's an increase of 7. Now we can notice a pattern. Every time we're increasing by the next odd number, right? First 3, then 5, then 7. So on our 6th tile, so the first one, from the first to the second, we increase by 3. From 2 to 3, that's 5. 3 to 4 is 7. 4 to 5, that's going to be our next one. That's 9. 5 to 6, our next odd number is 11, and 6 to 7 is our next odd number. That's 13. Okay, we've got a board game spinner that's divided into 3 regions. So region A has probability 1/3 of being landed in. B is 1/2. And we want to know C, right? So the way to figure out C is to figure out how much of the region we're missing. So we've got 1/3 of the circle accounted for, that's region A. We've got half of the circle accounted for, that's region B. So what are we missing? So what do we have so far? Let's figure out what region A plus region B is. So we need to add fractions, and the way we're going to do that is by finding common denominators, right? We want 2 and 3 to be turned into the same denominator. So a common multiple of both 2 and 3 is 6, right? 3 times 2 makes 6, and 2 times 3 makes 6. So we'll multiply 1/2 times 3 over 3. So 1/2 is the same as 3 over 6. 1/3, we'll multiply that by 2 over 2. That equals 2 over 6. All right, so now we have 3 over 6 plus 2 over 6. And that equals 5 over 6. So that means that 5/6 of the circle is accounted for. So we have 5/6 of the circle accounted for. How much of the circle isn't accounted for? That would be how much of the circle is region C? Well, the entire circle is 6/6. So minus the 5/6 that we already have, that is 1/6 of the circle left over. Okay, so we have Bert who has a box of jelly beans. So let's draw Bert's box. It doesn't have to be very fancy. I just like to visualize things. Okay, a few weeks later, Carrie gets a larger box full of jelly beans. It's twice as high, so we've got 2 times the height. Twice as wide, that's 2 times the width. And twice as long, that's another 2 times the length of Bert's box. Dang, that's a lot bigger. So we want to know how many jelly beans Carrie got. So Bert's box, it doesn't have 2 times the height, 2 times the width, or 2 times the length. It just has the normal height times the normal width times the normal length. And we know when that happened, that box held 125 jelly beans. Okay, so what about our new thing? What about Carrie's box? Well, we've got 2 times 2 times 2 in this equation, right? 2 height times 2 width times 2 length. We can take all those 2's to the side and make 2 times 2 times 2. That's 8 times height times width times length. And we know height times width times length, that already equals 125, right? So we can substitute in 8 times 125 jelly beans to figure out how many jelly beans Carrie got, right? Because height times width times length already shows the volume that Bert got, and Carrie, we found out, has 8 times that amount, because all dimensions of her box increased by 2, or doubled. So 8 times 125, that's 1,000. Answer choice E. Okay, we've got a large group of items at 30% off. Later, the merchant takes 20% off these sales prices and claims that the final price of these items is 50% off the original price. And we want to find out what the discount actually is. All right, so what I find helpful is let's just do an example. Let's figure it out. Let's say a merchant's offering something that costs $100. So he's taking 30% off of that price. So what's 30% of 100? Well, that's just 30, right? So 100 minus 30. So now the merchant, he took 30% off of the items, and they're being offered for $70. Later, the merchant takes 20% off of this sales price. So 20% of 70. What's 20% of 70? Well, we can just multiply it to find that answer. 0.2. Let's do some multiplication. 2 times 0 is 0. 7 times 2 is 14. And we've got 1 decimal point. So we find out that the merchant takes $14 off of this $70 thing. So 70 minus 14. That's $56. Okay, so originally it was $100, now it's $56. How much is that discount? Well, we took away, to get from 56 to 100, that's adding 44, right? 56 plus 44 makes 100. So the total discount is 44% off, right? We lost $44 from the original 100, and now we're at $56 as the sales price. So basically, what this is showing is if you're not sure how to tackle a problem, it can help. You could just set numbers arbitrarily, right? We don't know how much the items originally cost, but we can just say, okay, like, they can be $100. We'll just, like, without loss of generality. So what that means is, like, we can just set it to $100 and the problem still needs to work. No matter what we set our original price to, it's still going to work. I just chose 100 because that makes it easier to do the solving. So we found the new price is $56, and that takes $44 off of the $100 that we started with. So it's a $44 discount. Okay, now we want to find out which of the following polygons has the largest area. All right, let's figure that out. So what about polygon A? Let's say that for this grid, oops, that's a little confusing. For this grid, the distance between dots, we'll call that a distance of 1, right? So that means that one box has area 1. Sorry. Using that, we can figure out what our area is, right? So let's break it down into boxes. So first, in A, we've got one box. Why don't I just draw it out? We've got a triangle, we've got a box, we've got another box, and another triangle, and then 2 more boxes on top. Right? So each of these boxes is going to have area 1. And then these triangles, they actually take up half of a box, right? It's cutting it straight down the middle. So this is half of an area, half, or just half. And the other triangle also has area 1/2. So that means that shape A has area 1 plus 1 plus 1 plus 1 plus 1/2 plus 1/2. Right? We're adding up all of the smaller regions, all of the boxes, plus all of the triangles, and that's giving us an area of 5. All right, let's move on to the next one. What about B? B has a triangle, and then a square, and another square, and another square, and a triangle, and a square. So each square has area 1. Each triangle has area 1/2. So we have 1 plus 1 plus 1 plus 1 plus 1/2 plus 1/2. That is 5. Again, another triangle with area 5. Okay, what about E? We've got a triangle, a square, a square, a triangle, a square, a square, and a triangle. Okay, remembering again, those squares have area 1, triangles have area 1/2. Adding that up, we get 5.5. Okay, so that's something bigger. All right, letter D. We've got a square, a square, a triangle, a square, a triangle, and another triangle. So squares have area 1, triangles have area 1/2, right? Base 1, height 1 divided by 2. 1 times 1 over 2 is 1/2. So that has area 3 plus 1/2 plus 1/2 plus 1/2. That's 4.5. Okay, last one. This one's a little trickier looking at it. So we've got a triangle for C, a square, a triangle, another triangle, ignore my bad drawings, another triangle, and another triangle, and another triangle. That might be a little bit confusing. I could try drawing out all of the triangles, but it's not very easy to visualize. Anyway, triangles have area 1, have area 1/2, squares have area 1, so that's 1/2, 1/2, 1/2, 1/2, 1/2, up here 1/2, plus 2 squares, so that has a total area of 5. So which has the largest area out of all of them? That would be answer choice E, with 5.5. Okay, we want to find which one of the following is true. We want to find out basically the areas of these triangles, right? So let's draw this out. We've got triangle W, triangle X, Y, and Z. And what we know is that these triangles are isosceles, right? So that means that for Z, this side is the same as this side is the same as this side, and this side is the same as this side, right? Isosceles, that's two of the same. That means two sides of the triangle are the same, at least two sides. Okay, so now let's find area, or let's fill in what we have. So we know that this side is 5, this side is 3, and this side is 4. Then, based on what we've written down, this side also has to be 5. Here's another side that has length 3, and okay. And now that we have a base and a height for all of our triangles, we can actually find all of the triangles' area, right? Let's start with Z. We know Z has base 5 and height 5. So what's its area going to be? That's an area of a triangle is base times height over 2. So 5 times 5 over 2, that's 25 over 2 for Z. What about X? We know that X has side length 3 and another side length 3. 3 times 3 is 9 over 2. 9 over 2 is X's area. Okay, now Y. Y has base 4, height 4. So 4 times 4 over 2. 4 times 4 is 16. Divide that by 2. Y has area 8. Okay, now lastly we have W, the one in the middle. We see it has height 3, base 4. 3 times 4 is 12. Divided by 2 is 6. All right, now let's figure out which of these equations is true. So first we have X plus Z equals W plus Y. Let's try that out. X and Z, we have 9 halves and 25 halves. Adding those up, 25 plus 9, that's 34 halves. 34 divided by 2 is 17. And then what's W plus Y? 6 plus 8, that is 14. 17 does not equal 14, right? So that means A is incorrect. Now we have W plus X equals Z. W is our inside, that's 6. X is 9 halves. And we want to see if that equals Z, so 25 halves. So what's 6 plus 9 halves? Well, 6 is the same as 12 over 2, right? We can multiply 6 times 2 over 2 to convert it into a fraction. So 6 times 2 over 2 makes 12 over 2, plus 9 over 2, that is 21 over 2. And 21 over 2 does not equal Z, right? Z is 25 over 2. So B is also incorrect. Now we've got C. 3x plus 4y equals 5z. Well, x is 9 over 2, so multiplying that by 3 is 27 over 2, plus 4y, y is 8, so plus 32, 4 times 8 is 32, equals 5z. Z is 25 over 2, multiplying that by 5 is 125 over 2. Okay, why don't you take a second to solve for that? Solving that, you'll get 91 over 2 for 3x plus 4y, which is not the same as 5z, which is 125 over 2. So that is also incorrect. All right, looking at our last two equations, I think E looks like it'd be easier to try out. So why don't we try E? X plus Y equals Z. So we know X, 9 over 2 plus 8. 8 is the same as 16 over 2. So we want to find if 9 over 2 plus 16 over 2 equals Z, which is 25 over 2. 9 plus 16 is 25. So we've got 25 over 2. So that's correct. X plus Y does equal Z. And we're done with that. All right. A student gains 5 points for a correct answer. So correct, 5 is for correct. 2 points for an incorrect, so -2 for an incorrect. Okay. So we see Olivia answered every problem and her score was 29. Okay, so there's 10 problems, right? And if she answered all of them and she got all of them right, that'd be 10 times 5. That'd be 50 correct things. So that's not what happened. So we know that Olivia got some wrong. So let's figure out how many she got wrong to figure out how many were correct. Why don't we start with A? Let's say Olivia got 5 questions right. So if she got 5 right, that means she'd have 5 times 5, she'd have 25 points. Minus the 5 that she got wrong, right? Because if there's 5 right, then there's 5 wrong if there's a 10-question test. So 5 times 2, that's minus 10 points. So 25 minus 10, that's 15 points she would have if she answered every question and got 5 right and 5 wrong. So that's not what happened, right? Because we want a score of 29. So let's go to the next one. What if Olivia got 6 questions right? Then she'd get 5 times 6 points for being correct, so that's 30, minus 4 times 2 points for being incorrect, right? Because if there's 6 right, that means 4 wrong. If there's 4 wrong, that's minus 8 points. 30 minus 8 is 22, so that's not right either. We're still looking for 29. Okay, let's say she got 7 right. So she gets 5 points for each right one, so that's 35 points for getting 7 right. Okay, and if there's 7 right, that means there are 3 questions that are wrong. Every time she gets something wrong, she loses 2 points, so that's minus 6 points. 35 minus 6, that's 29, and there's our answer. Right, we're looking for a score of 29. Getting 7 right and 3 wrong yields a score of 29 for Olivia. Okay, Gage skated 1 hour and 15 minutes each day for 5 days, and 1 hour and 30 minutes each day for 3 days. How long would he have to skate on the 9th day in order to average 85 minutes of skating for each day for the entire time? All right, let's figure out some minutes first, right? Because we see our answers in minutes, so we want to start with that. So skating an hour and 15 minutes, that would be 90 minutes worth of skate, or not 90, 75 minutes worth of skating, right? 60 minutes in an hour plus the 15 is 75 minutes of skating for 5 days. And then 1 hour and 30 minutes, there's our 90 minutes worth of skating for 3 days. So skating, and we want to know how much he would have to skate on the 9th day to average 85 minutes. Okay, so we know that's 75 minutes for 5 days. So let's find some averages here. 75 times 5, that's 375 minutes of skating for the first 5 days. Okay, and then 90 times 3, that's 270 minutes of skating for the next 3 days. So in those first 8 days, Gage skated 645 hours, or minutes, not hours. That'd be kind of a lot. Okay, and we want to know if on the 9th day, how much he would have to skate to average 85 minutes. So we want an average of 85 over 9 days. So we want our sum of minutes, the total minutes spent skating, to add up to 765 minutes of skating. So Gage has already skated 645 minutes, and we need him to skate 765 minutes. So how much more skating does he have to do? Subtracting, we get 120 minutes. 120 minutes, simplifying that down, that's 2 hours worth of skating that Gage would have to do on day 9 to average 85 minutes for that 9-day period. All right, that's it. Hope you have a great day.